Here we are on packet tracer number 6. This is packet tracer activity 5432. This is Brian Torres, and we are going to be examining the Linksys GUI for the NAT configuration. Basically what this is going to tell us is how NAT works to give an address to a device that's tried to hook to the internet or to an outside IP address, basically, to keep it secured from the rest of the outside networks. The first thing we're going to do is we're going to look at the way the Linksys device is set up. So I'm going to click in the GUI here, and we're going to look at the status. And in the status here you can see that we have an internet IP address 209.165.200.227. So this is not an internal address. This is an external public address. You can see the DNS servers there. So when we look at the local network, we see that our router actually has an internal private address of 192.168.1.1. We have a starting IP address at 192.168.1.100, and then we go to .1.149. So we have 50 users that can be set up on that. We can verify that right here in the maximum number of users. So there we go. That's what our internal configuration looks like. Now we're going to connect some PCs to this device and see what she does. So we're just going to pick 3 or 4 computers. I'm going to pick straight through cable. Going to hook each one to an Ethernet port. Pretty straightforward, simple connection. But before we can continue, we're going to wait for everything to receive an IP address, because the Linksys router had DHCP enabled. We'll wait for all the PCs to get a IP address before we continue on. Or actually just establish a link. We're going to go through and actually turn DHCP on each computer. So as you can see here, nothing's set up. We don't have a gateway, we don't have a DNS server, we don't have an IP address. So now that everything is connected and communicating, we'll come in here, we'll turn DHCP on. Same thing as if we had done it there. It's just a quicker way to do it. In here we actually see the actual IP address, whereas if we do it for the settings tab, we just see the gateway and the DNS server. We can actually go in here to the command prompt and do an ipconfig all, and it'll show us our IP address, our subnet mask, our default gateway, and our DNS servers. So each one of them will actually do this for us. We don't actually have to go through the settings. It's just kind of a slower, more bloated way of doing it. Whoops. Maybe we should actually... There we are. And as you can see, each one's getting a different unique IP address, but they're all on the same subnet mask, they're all using the same default gateway, and they all have the same DNS servers. this again. And there we are. So, there's that. Let's go back through and close all these windows. There we go. Now we're going to look at the NAT translation across that Linksys device. So we're going to come in here and we're going to create a complex PDU under the simulation tab. The complex PDU is the open envelope. So we're going to click him. We're going to go and edit our filters. This activity wants us to use HTTP and TCP. And basically this is just so that the packet is going to actually require a confirmation, a destination confirmation message sent back. So here we're going to pick, I'm just going to pick PC0 because we're supposed to pick one. Our application type is HTTP. Our interval is going to be 120. Our starting source port should be 1000, and this was all set by the activity itself. I guess we were supposed to click this guy first. There we go. There's our destination IP address, and everything else stayed the same. So now we're going to actually create the PDU. This guy's undocked already, so we don't have to undock it. And now we're going to play this and watch what happens. So you saw the packet stopped there at the router, it was sent back, and then it sent it again. That was because of the NAT. It got a new address, was sent back, said, hey, this is your address, and then it got to continue on from there. So now here it's going to go through the motions. And actually, if we take this out, we can see all of our TCP. And there we are. Our buffer's full. We can close this. We're actually going to come up here and view the third line, which the last device was PC0. This is where it was sent to the router after the PC sent it to the router and it got sent back. Then it landed here again. And here we can see our inbound source IP was 192.168.1.100. That was what the PC0 had to begin with. The destination IP was the Cisco router, or the Cisco server, which is the 209.165.200.228. However, because this was a private address, it could not go public across the internet until being translated. So then, the router assigned an external IP address, and it matches up with the destination IP address. And we're supposed to look at a couple of others. Maybe we could look here at this one. And this one didn't have an outbound. It was, oh, I clicked the wrong one. There we go. Let's look at that one. Its inbound source was a NAT translation, and its outbound was the same. So now if we come back to one that's inside the switch, or the router, I mean. Let's look at this one again. Now this one says, oh, your source was the Cisco Learn server, and your destination was actually here. Actually, this was the NAT address it was assigned. And that's about it. It's how a router sends a packet through with NAT. If we look here, check our results. There we go. We completed it. Yay!